Well, hey there, you're probably going to hear lots of background noise. I'm sitting here in front of my iMac about to do another podcast. I've got two kitties in the house. You might hear them talk or knock down some stuff. And got the windows open because it's pleasant weather, so you might hear some stuff from outside. So just ignore it if you get bothered by it. Alrighty, this one's going to be on more nomenclature, which will be about acids, how to name acids and write formulas for them, and about molecular compounds, how to write their names and how to write their formulas. So let's go ahead and get started. We'll learn how to recognize acids, name them, and write formulas. So acids, I want you to be able to recognize because they're always going to have, at least for what we do at this point in chemistry, hydrogen ion, which is H1 positive, as their cation. Remember, cations are written first in an ionic compounds formula. So you want to look at the first element present and see that it is hydrogen or multiple hydrogens depending upon what the charge of the anion is. Since the cations are all going to be the same, we can't determine the name of acids based on their cations. Therefore, the names are determined based upon the name of the anion that is present. And I'm going to help you out and put the phases of the acids that I give you in aqueous phase. AQ will be written to the right in parentheses of any acid that I give you. So there are essentially three possible endings of anions. Those are ide, IDE, ite, ITE, and ate, ATE. So I'm going to go over how to name acids that have anions beginning with each of those. We'll start with IDE. If you have an acid whose anion ends in IDE, to name it, you're going to drop the suffix IDE, leaving the root word, and then you'll add hydro as a prefix and IC as a suffix. You'll then end with acid as a separate word. So let's take HCl as our example of this. When I look at HCl, I don't have AQ written behind it, but I will in any practice problems that I give you. You recognize it's being an acid because H is the cation. The reason there's only one H is because Cl's charge is 1 negative. H's charge is 1 positive. You do your crisscrossing business like I taught you with ionic compounds, and you get HCl. Well, the name of the anion is chloride. I'm going to drop off ide, and I'm left with chlor. So chlor is my root word, is what I'm referencing. I'm then going to add hydro as a prefix of chlor, and I'm going to add ic as a suffix of chlor. And then I add acid as a separate word. So as you see on my exciting slide there, I say Shazam! You get hydrochloric acid. Okie dokie, so that takes us to anions that end in ITE. If an anion ends in ITE in an acid, you're going to drop the suffix ITE to leave the root word. You're then going to add OUS as a suffix. Notice there's no prefix added in this one. The only acid that will get a prefix is when the acid has an anion ending in IDE. You're then going to add acid as a separate word. So let's take a look at having H2SO3. Well, there are two H's there because SO3's charge is 2 negative. And H's charge, remember, is 1 positive. You do your crisscrossing thing, you end up with H2SO3. The anion name, SO3 2 negative, is sulfite. You're going to drop off ite, and you're left with sulf. And I chose this one as an example because sulfur and phosphorus are weirdos, so I wanted to show you at least one of them. So in the case of sulfur and phosphorus, you have to do a little more than just add the suffix. In the case of sulfur and phosphorus, where you're left with sulf and phosph, you're going to make it sulfur. Sulfur is what it looks like, but it's pronounced sulfur. And in phosphorus's case, you're going to be left with phosph, but you make it phosphor. So I'm left with sulf, but I'm going to make it sulfur, and then it becomes sulfurous acid rather than sulfus acid. It's sulfurous acid. And I'm sure I have some other, I have ooh-ah on this slide saying it's sulfurous acid. So again, sulfur and phosphorus are the weirdo ones there. Alright, so then we have anions that end in ate. If you see that you have an acid whose anion ends in ate, you're going to drop the suffix ATE, leave the root word, add ic as a suffix, no prefix once again. The only one that gets a prefix is the anion that ends in IDE. And you're going to add acid as a separate word. So again, I picked similar thing to sulfurous acid, only this time the anion is sulfate. It's H2SO4 this time. You're going to drop 8. You're left with sulf. Think about what I just told you. You're not going to make it sulfic acid. You're going to make it sulfuric acid. So, let me see what exclamation I put on this one. Waka waka, as Fozzie the Bear said, sulfuric acid. And I put the same little note about sulfur and phosphorus on the slideshow, just so you'd be encouraged to get that stuck in your brain. And I'll give you some practice on this acid nomenclature stuff in just a bit. It's actually a pretty short podcast, so I'm not too far from being done. The next thing we're going to go over is molecular compounds. Molecular compounds are always made of nonmetals. In our case, we're just going to work with what are known as binary molecular compounds for right now, which means they contain 2 nonmetals. I want you to consider boron and gallium to have nonmetallic properties in any of the stuff that we do. And you're going to use the same prefixes that you used for hydrates. Those I'll go over in just a moment, but they indicate the number of atoms that we'll have in each molecular compound. And every molecular compound's name will end in IDE. Alrighty, the prefixes, as a reminder, are mono, di, tri, tetra, penta, hexa, hepta, octa, nona, and deca, representing numbers 1 through 10, respectively. You're going to use the prefixes on the first element if there is a subscript. If you don't see a subscript, you do not use a prefix on the first element. On the second element, you always use a prefix, even if there is no subscript. If there is no subscript, it's understood that the subscript is 1. So the first example I'll give you is CO. It's molecular because we don't see a metal in it. It's made of nonmetals. There's only 1 carbon, and it's the first element in the compound, which means it doesn't get a prefix. There's only 1 oxygen, but it's the second element, so it always gets a prefix, and its prefix is mono. Now, when you apply mono to ox, you don't want mono and then ox because it's going to look like it says monooks, and boy, that's just weird. So you're going to drop the O off of mono when you apply it to ox. We're going to add "ide" to the end of ox as a suffix to that root of the element name, and then we put them together, we get carbon monoxide rather than carbon monoxide, carbon monoxide. Okie dokie, the next example I'm giving you is N2O4. There are 2 nitrogen atoms, 4 oxygen atoms. Okay, look back at those prefixes if you have to. And what'd you come up with? Let's hope that it is dinitrogen tetroxide. Woohoo! Okie dokie. What you'll see on the next slide is a little bit of practice. I've given you 10 formulas that I'm going to ask you to name. So I'll ask you to look at it, write down your names, stop the PowerPoint, and then restart the PowerPoint, not PowerPoint, excuse me, the podcast, restart the podcast when you have written your answers, and I'll give you the answers real quickly and check them. So go ahead and stop the podcast, write down what you see on the slides, names, and then turn it back on, and you'll hear me give you your answers. So I'm going to go down the columns. You have chloric acid, carbon disulfide, phosphorus trifluoride, hydrocyanic acid, nitrogen dioxide, phosphorus acid, boron triiodide, and yes, there are 2 I's together there. This one is funny. It's per-iodic acid, but it looks like it says periodic acid. Aren't you giggling? Diphosphorus pentoxide and oxalic acid. And then on the next slide, I've given you 5 names, and I want you to write formulas for them. So, again, stop the podcast, write your formulas, turn the podcast back on, and listen to my answers. So go ahead and stop the podcast. Alrighty, here are your answers. OF2, H3P, CCl4, HClO2, and H2CrO4. Alrighty, well, this one is a really brief podcast. I don't remember last time I did one this short. You hear a dog barking in the background. That would not be mine. It's outside somewhere. You might hear Mr. Mooch, the little bitty kitty, scratching around here somewhere. He gets all excited thinking that I'm talking to him. Mr. Linden's probably mad because Mooch is in here. You know the rigors of cat ownership. Woohoo! Alrighty, the next one that I do will be on empirical and molecular formulas. I apologize for not doing one on ionic compounds, but that is such a detailed thing that it's much easier for me to teach you in person. Therefore, I didn't feel like it was advantageous for me to narrate along with my PowerPoint. But you can certainly access my PowerPoint on ionic compounds on my Google Pages homepage. And you'll find a practice sheet on that homepage with some of this acid and molecular compound nomenclature. Hope you have a great day. Thanks for listening. Bye.